little bit background of MIHIR. MIHIR is a federally funded research and development center. We do work for the federal government primarily. As a federally funded research and development center, we're not allowed to do products, so that allows us to provide more unbiased advice to our clients. In this particular case, right now we're working with CMS and supporting them to help state Medicaid agencies meet some of the high-tech requirements. So we're doing lots of things like reviewing state Medicaid health plans and things like that, and trying to provide them with advice of how best to meet the high-tech requirements as well as MIHIR requirements. So I want to talk about some of the work we did last year. This work was done for the Veterans Affairs Office, but a lot of the things that you're going to see can also be equally applied to state Medicaid agencies. So we're going to talk about the task overview. There were two parts of that task. There was the development of secure REST interface profiles, and then we also did a pilot to implement those profiles. I want to talk a little bit about the pilot implementation, the next steps that we'd like to pursue, and connections with other related efforts, and then where you can get some more information. So the background, we did this work last year for the VA, specifically for the Office of Information and Technology, the Architecture, Strategy, and Design Division. And I think, you know, the important thing to get out of this presentation is that the things that we put together were not just designed for the VA and not just designed necessarily for health information, but can be used across a lot of different types of domains and a lot of different organizations, including state Medicaid agencies and health information exchanges. And so we wanted to use standards like OAuth and OpenID Connect, and we then did a profile to, a pilot implementation to verify those profiles. So the technical team was made up of Mark Russell, who is out of the MIHIR Cybersecurity Technical Center, Justin Richer, who is a member of the MIHIR Information Technology Tech Center, and myself. I'm in the Open Health Services Department. The project was run by Mary Polemacher and Mike Dow. And the project had a schedule last year. As I mentioned, there were two parts. The first part was completed in June, end of June, which resulted into version 1.0 of the profiles for both OAuth 2 and for OpenID Connect. And then the pilot software was completed on December 19th. And then we did additional profile updates as a result of that implementation and pulling in the lessons learned on January 12th. So this built upon really two projects that we've done previously. One was Restful Health Exchange, or REX. What that does is allows secure RESTful exchange of health information using OpenID and OAuth 2, OpenID Connect and OAuth 2. And what we did there, that culminated in actually a pilot or a demonstration at HIMSS back in 2012. We partnered with MiHIN, Health InfoNet, to essentially track a patient going across various different hospitals in the Maine. In this case, someone was on vacation. They were bitten by a tick and went to see an emergency room near where they were vacationing. Then they went back to their home and had a follow-up visit with their doctor, and that showed that they had Lyme disease. So not a great result for the patient, but it showed, as you went through the various different hospitals in Maine, it showed that you could see the updates in real time at the HIE. And also we had a mobile device, an application, H-Reader, which we also worked on at MIHIR to then show that information to a clinician or to a patient. And all that was being done in real time. And so we were doing this back in 2012 when a lot of the states at that point were just showing basic connectivity. The second project that we did was Blue Button Plus, and I'm sure a lot of you are familiar with Blue Button. Blue Button is, it allows you through a username and password to get access to your, and to get an ASCII dump essentially of your health information. Blue Button Plus wanted to add a little more structure to that, do it in XML or JSON. Originally, I think they were doing it in consolidated CDA. Now I think they're doing it in FHIR. And they also wanted to add some additional security to that. And so they were working on that, and they brought MIHIR in to help out with that. And so we got them into using a standard OAuth implementation to implement the security behind Blue Button Plus. And so from those two projects, that's kind of where the profiles came from. and sort of a best practices of how to use OAuth 2 and OpenID Connect. So, standards can have varying degrees of specificity, and OAuth 2 is a particularly loose standard. It can almost be an authorization framework rather than a protocol, and that's really to allow it to work with a lot of different use cases, but often that can be at the expense of interoperability and some security there. So, I mean, you've probably heard there have been a couple of instances of breaches of an OAuth 2, and a lot of that's because of the openness of the standard. And so what we wanted to do is try to impose constraints on that using best practices of how really to lock down the standards, turn some shoulds in the specifications to shoulds and mays into musts, and then incorporate some of the countermeasures for known attacks. And so on this chart, on the left side, in the original specification, it says that the authorization server should have clients register the redirection endpoint prior to utilizing the authorization endpoint, and the authorization server should require the client to provide complete redirection URI. And the profiles say clients using authorization code or implicit grant types must register their full redirect URIs, and the authorization server must validate the redirect URI given by the client at the authorization endpoint using strict string comparison. And likewise, it talks about the access tokens and how they can have different formats, structures, methods of utilization based on the server resource server security requirements, and which is very open. And our profiles say the server must issue tokens as JSON web tokens with, at a minimum, the following claims, and we list those claims. The access tokens must be signed with JSON web signatures, and the authorization server must support the RS-256 signature method or tokens, and may use other asynchronous signing methods. So we still provide some optionality, but really, we're trying to clamp down on some of the areas where OAuth 2 had some security breaches. So why build a pilot? So we want to show that this stuff actually works, and we want to provide demonstration code for people to see and actually play with. We also wanted to get hands-on experience ourselves with, how are these profiles implementable? Can we actually build them? And also get a sense of where the outside software library support stands. Can they support the existing library, support what we want to do, or do we have to write new software? And of course, the importance of running code. A standard isn't a real standard unless a lot of people are using it. And so where we are right now is we've talked about leveraging the two projects that we had done before. We've drafted the profiles for OAuth 2 and for OpenID Connect. We've created the pilot, so we're vetting those technologies, validating them, and we're in the process of engaging the community. So letting people know about what we're doing and how these profiles can help, and opening it up to have people poke holes in it, maybe adopt it and use it. Just want to make sure that that people know that it's out there and try to build a community around it. So the pilot goals were to do this in open source. In fact, it was done, started off with a README file and grew from there. We wanted to maximize use of open source components, existing ones, so we didn't want to reinvent the wheel. We wanted to validate our profiles. And we wanted to also assess the capabilities of existing libraries to support the technologies that are required in the profile, and to identify any gaps that might be there so that we can fill those gaps. There were some VA REST security patterns that we exercised, although these are things really that security patterns that can be used in a whole bunch of different types of organizations, not just VA, based upon who's the identity provider and who's a relying party for this type of information, security information. So even though it's VA security patterns, these patterns are really applicable to almost any type of organization. And again, we used a VA specific use case, but this, and I'll talk about that in a minute, but that can very easily be configured as a state Medicaid agency use case or an HIE use case. So the patterns we wanted to show, there's identity federation, with the VA as the relying party, this allows the VA to accept requests from outside entities to get access to their data. That we also did as the VA as the identity provider, in which the VA is using their identities to access outside information from external partners. We also showed how a patient can get access to the record using, in an application, say a mobile application, they can delegate their access to that application using OAuth 2. We can show how clients can access resources across multiple security domains, and we can show how a doctor can pull a patient's information from a remote provider. And you'll also see that in many cases there's a dialog that shows up that indicates where the patient can indicate what type of data they want to share with various applications and with various doctors. So in the scenarios, we have Steve, who's a veteran, but this could be just as easily as a Medicaid patient. And he's able to link his medical record at the VA to an account with his own identity provider, and he can use that to access a VA web portal to get, so that he's logging into the VA system using his web browser to access his own information. The second thing that we're showing is that Steve can delegate access to a mobile health application to give that the capability of pulling information from the VA to do whatever it needs to do, whether it's a fitness application, an analytics application, or whatever. But Steve is giving his permission for that application to access that information. While on vacation, Steve has an accident and visits an external non-VA ER. In this case, in this state Medicaid agency, it could be an ER in another state, for example. And he's able then to delegate access to to his longitudinal VA records to the ER system, so they know what medications he's taking and what his conditions are and so forth. And then finally, when Steve gets back from home, his VA doctor is able to access what happened, the records about what happened at the ER, and then transfer the relevant information back into his VA medical record if they want to. So those are the basic scenarios, and this really demonstrates secure RESTful exchange. We're using open standards widely used on the web today, REST, JSON, OAuth, and OpenID Connect. And of course, the pilot validates our security profiles. We're exchanging information. All the information is being exchanged using FHIR, which is a rapidly emerging standard for in HL7. And we wanted to show that Steve can access his health records and allow other people to do that as well across, in this case, 3 different security domains. And so, as I mentioned, there were some other projects that this leveraged, but there's a couple of others. One is MITRE ID Connect, which is an open source reference implementation for OpenID Connect and OAuth 2, and that was developed in partnership between the MITRE Corporation and MIT. Back in 2013, we did a project called Vista Novo for the VA, which provided a RESTful FHIR interface to Vista, or any other EHR really. We also leveraged several existing open source libraries. We used OmniAuth, which is a Ruby-based authentication framework that has OAuth and OpenID Connect support built in. We had to make some modifications to do that, to support what we were doing in the profiles. There were also used a library called Nimbus, which provided POSE and JSON Web Token capabilities on the server side. So all of the code is written for the pilot is an open source and available on GitHub. So these are the 3 security domains. We have the patient domain, we have the primary provider, and the secondary provider. And we have VA and ER in here, but this could just as easily be State Medicaid Agency 1 and State Medicaid Agency 2, or HIEs, or whatever you want to put in there. So there's nothing here that's necessarily specific to VA or ER or emergency room. So in each of these cases, in the patient domain, the Steve can delegate access to the VA health records through a health tracking web app that I talked about earlier. Steve can also, when he's at the VA, he can access the VA record through the VA systems using his own identity. And then while on vacation, Steve can set it up so that the VA, the ER can get access to the VA records, and then vice versa. When he gets back home, the VA can get access to see what happened at the ER. And so, looking at the first case, Steve logs into the VA with his an existing account at an identity provider, say in this case example.com, instead of actually creating a new account at the VA. And so the VA would then accept that as a trusted provider of identity. In this case, in storyboard 2, we have Steve giving permission to his health tracking application to access his VA records. And as you can see, there's a dialog that pops up during that, and essentially asking Steve, what do you want to provide access to? And these are based on some of the various different FHIR resources that are available. And so Steve can say, well, I want them to see this, but I don't want to, I want them to be able to see my medications, but I don't want them to be able to see my allergies, for example. And this, you probably have run into this on the internet before. When if you go to a website and you want to, sign in using your Facebook account or your Twitter account, and often times you'll get a dialogue saying, well, this application wants to access your friends and things like that. That's the same thing that's happening here. So if you've seen those kinds of dialogues, you've already used this technology. So in the plot, Steve gets into a car accident and is taken to a non-VA emergency room. Again, that could be an ER, for example, across state lines. And in this case, Dr. Pellegrino at the ER asks Steve what medications he's taking. And so Steve is able, with his digital identity, provide that to the ER doctor, and so that he can get, or he or she can get access to Steve's VA records. And so, but that doesn't allow the ER doctor to see any of the other information that Steve did not check. And then when Steve returns back home to see his doctor, Dr. Feelgood, Dr. Feelgood could then use his identity at the VA to get access to the ER system, EHR system, and get the condition information and pull it back if they, necessary into the VA EHR. So there's a couple of things that are not shown here. It doesn't show how Steve's example.com account is authorized to access his medical record. This could be, this could happen while he was registering at the VA or at the ER. This requires the FHIR server to have a mechanism for doing that, and that was out of the scope of the pilot. There is another pilot that INSTIG is doing with Inova Fairfax Hospital that does demonstrate how this could work, and the URL for that report is shown there. The pilot also doesn't, in this case, Steve's VA doctor is explicitly granted access by name to his ER record, and that was kind of set up manually ahead of time before we did the pilot. There's another technology called User Managed Access, or UMA, that can do this much more dynamically based upon a policy-based user-defined access control. So Steve can basically say, almost by role and everything else, say, I want oncologists to be able to see this information, or things like that. And even without Steve's necessarily being involved in the interaction. So if Steve, for example, had arrived at the ER system, and he was unconscious, if he could have set up all this ahead of time with UMA, and Steve would not be it would not have been necessary for Steve to sort of manually go through and allow access to the ER system. Unfortunately, UMA was not really mature enough to profile and demo last year, but the HEART working group is working towards creating UMA profiles for this type of use case. So there's ongoing work there. Also, we didn't show how the Steve's VA doctor imports data from the ER's EHR system back into the VA's EHR system. I mean, we showed the information on the screen, so technically it's possible to do that. However, there's a lot of kind of difficult policy decisions around that. You know, whether you want to actually copy the data, whether you just want to have a link to it. You know, how do you want to you know, track the sources of that data and so forth. So there's a lot of open questions there, which was really outside of the scope of what we wanted to show in the pilot. So in the pilot implementation, there were 10 different components across the 3 different domains. And so in the patient domain, these are services trusted by the patient. They can either be run by the patient themselves, they can be services purchased by the patient or just made available to the patient. There's a mobile application, which is the icon on the right, and that's a FHIR client that can, you know, read data and aggregate data from multiple areas or multiple organizations. And then there's a personal identity provider, which provides the digital identity for the patient that the patient trusts, and then that also that identity provider also needs to be trusted by the various organizations that you're trying to access. At the VA, you have an identity provider, which provides the identities for the personnel within the VA, or this could be, again, State Medicaid Agency, or HIE. And there's an authorization server, which is what actually protects the APIs from unauthorized access. There's a VA, and then there's a FHIR server that contains all the patient records, and it interacts with the authorization server to within its domain to determine whether to provide access. And this is mirrored onto the other side, the ER side as well. So exactly the same functionality, just on the other side of within the ER domain. All 3 areas have a user-facing data display. So, for example, the patient has his mobile application that he's running. The VA has a web portal that patients can access, and the ER also has a web portal that they can access. And then there is the servers themselves, the FHIR servers, and those determine which users have access to what records, and they accept OAuth tokens only from the local authorization server. So you're not getting cross-pollination here. They only accept the tokens from their own servers, authorization servers, and they only serve the records that are local to their domain. So they don't go, you know, providing access to stuff that they don't own. And then there's the identity providers. This provides the digital identities for, in this case, the patient in the blue, the VA in the green, VA personnel, and in the ER personnel in the red. And that's supported by the MITRE ID Connect software. And again, you know, this could be just as easily State Medicaid Agency 1 and State Medicaid Agency 2. The authorization server is the one that actually, you know, it supports both the client access as well as the FHIR servers. The clients access them to get the access tokens, and then the FHIR servers use the authorization server to validate those access tokens. So, but they allow logins across the domains, so that you know, somebody at the VA could access ER records with the appropriate authorization and vice versa. So we're going to go through a bunch of different diagrams, and I think you're going to probably see a similar pattern on a lot of them. The basic flow is very similar. It's just you're dancing with different dance partners along the way. So it's really almost an exercise in combinations. So in this case, we have Steve is logging into his VA records, the VA portal. So he's using his digital identity from his own from a server that he has or gets service to. That gets the token from the authorization server, which authenticates the user, and then the request goes to the FHIR server, which then calls the authorization server to validate whether the token is valid and whether Steve has the access to that information. And if so, then it returns it. In this case, it's instead of contacting the VA web portal directly, it's using an application on Steve's mobile device. So he's authenticating himself on the mobile device, which then gets a token from the authorization server, who authenticates Steve's use of that application. Then the request goes to the FHIR server, which then validates the token with the authorization server, and then if that's okay, it returns the resources. So again, similar flow, just different players. And this is exactly the same as the first case that I showed you with the VA, except now this is with the ER. So, it's, in this case, Steve is going to the ER's web portal, and everything is happening over on the ER side. In this case, Steve is allowing the ER access to his VA records, so he logs in using his personal identity into the ER web portal, and that gets a token from the authorization server over on the VA side, and the VA's authorization server authenticates Steve's digital identity, and then when the call is made to the FHIR server on the VA side, it checks with the VA's authorization server to validate the token before returning the information. So here you have Steve, essentially providing access to the ER system, his VA medical records, and he can specify what information he wants to share. Now that Steve is back from his vacation, he's able to give access to his doctor to access the ER records on his behalf. So in this case, Dr. Feelgood uses his identity to log into the ER portal and gets a token from the ER authorization server, which authenticates the user, and then when the request is made to the FHIR server, again, it validates the token with the authorization server within its domain, and if everything is okay, it returns the information. And so in this case here, what we have is pulling the data back from the ER system back into the VA system. So in this case, the Dr. Feelgood logs into the VA portal, and the VA portal then accesses the ER authorization server to get the token, which validates Dr. Feelgood, and then gets the information so that it can be stored in the VA system. So again, a lot of different flows there, but they're all kind of doing the same kind of thing, just different players. So here's the pilot architecture. We had a FHIR client, which was a Ruby on Rails application. As I mentioned, it used the OmniAuth security library, and OmniAuth has a variety of strategies that you can tie to it. One of them is OpenID Connect, so we use that. And then OAuth was provided by another gem called gem is another word for software library in Ruby land. So the RACOAuth 2 library provided the OAuth capability. And then over on the resource server side, that was using Vistanova, which is the FHIR-based API was provided by a Node.js application, and used MongoDB and JavaScript to do that. And then we had a test stub, which sort of mocked an electronic health record system. We weren't actually on top of any particular health record system. The stub provided that. And that used a variety of web UI components and things based on Ruby. It used a SQLite database, but that could easily be changed for something else. And it used a Faraday HTTP client to make calls to the authorization server. So on the other components, we had the identity provider and the authorization server. These were both provided by MITRE ID Connect. They're both Java-based projects using the Spring framework, and using Tomcat and pretty standard Java setup, and they used Spring security authentication. So the way these all communicated with each other were through open standards, HTML, JSON, and FHIR, all going back and forth between the various different components. So everything is using open standards. And so the profiles can be implemented. We showed that the profiles can be implemented successfully, and that the profiles can enhance the security that's already provided by the OAuth and OpenID Connect implementations. There were some functionality gaps in the libraries, particularly on the client side. Most of the client libraries are centered around client ID and shared secret nomenclatures or implementations. Accessing Google and Twitter and things like that. And shared secret is kind of an oxymoron because you're actually sharing secret information. We had to change that to handle the Jose and the JSON Web Token functionality. We also found that the documentation for a lot of these libraries was lacking, and even some of the documentation for the standards themselves were lacking. So it was really unclear sometimes how do you sort of piece these things together to get them all to work as a cohesive unit. Sejal, did you want to say something? Okay. UMA could make and the other thing is UMA can make the implementation of the use cases much more practical. We had to set up a lot of things manually in the background, and UMA could make things a lot more dynamic. Which would be really required, I think, in a real world case. And so UMA is a significant piece of this, and so that's a potential area for further development. So we found that FHIR enables, you can get fine-grained requests for individual information, but it also, just to bring up a profile, you had to sort of make multiple calls to get medications and to get, conditions and allergies and so forth, and that sort of added. With all of some of the security attached to that, that's sort of created a lot of chattiness on the network. And so we put in a lot of caching of tokens and responses to help eliminate that. But then, I think the FHIR team is aware of this, and they're working on ways to reduce that. Because that's, bringing up an overall patient screen is kind of a common thing that you'd want to do. And so I believe now the FHIR team has sort of a get everything query, which will help simplify that immensely. There's another piece to these technologies of dynamic discovery and registration of clients, and that was feasible at the time, but it was really it was kind of out of scope with the amount of time that we had. But that's since become a standard now within OAuth 2 and OpenID Connect, and so. That will enable users to choose, clients to give them additional freedom, and things like that. So again, it adds to the whole dynamic, makes it much more dynamic, so you don't have to set things up manually all the time. So, our recommendation for the VA, and I think the recommendation for state Medicaid agencies as well, is that REST is pervasive and it is the future. It's already the dominant architecture of the web, and a lot more and more people are embracing it. It works really well with lightweight clients. SOAP can be very heavyweight, and it's difficult for particularly wireless devices and sensors to work with. Many other organizations are using REST for internal interfaces as well. The common profiles support integration with mission partners. There needs to be a common scheme for interoperability here. As I mentioned, OAuth 2 and OpenID Connect tend to be kind of more like frameworks rather than real, specific standards. So you need to sort of nail some of the details, the options down in order to get real interoperability across the board. There's because of the lightweight the lightweight capabilities of REST. It makes sense to, I think, to use those standards to support all of the various types of devices that can come in to play. And security, I think, REST is RESTful security is something that hasn't been as addressed historically, I think, as much as, say, SOAP is, for example, in the SOAP world, like in SAML and all of that. But there really are technologies that can handle security on the REST side, and that's what we're really trying to show. And so our next steps is to do more outreach and continue to use, try to get more and more people to use the REST security profiles. We're reaching out to all kinds of health and government communities to socialize the profiles and to try to get, invite people to poke holes in it, try it out, see what works, what doesn't work, where are the shortcomings, because the profiles are only useful if they're actually adopted and used. We're continuing to engage on standardization on various committees and things like that to try to move that forward as well. FHIR can provide some of these components for healthcare interoperability as well. But the idea here is we're trying to separate security and data concerns. I mean, even though we did the pilot with FHIR, you could just as easily do the pilot with consolidated CDA or something else. There's no tie-in between the data and the security that's going on. And we're trying to engage also with open source library developers. Like, for example, we did some stuff with OAuth, but there are lots of other libraries out there that I think could also benefit from these technologies. So we're looking to identify projects for pilot adoption. So, if there are things that, pain points regarding identity management in the state Medicaid agency world or HIE world, I think it would be great to put together some pilots to show that this technology can work in this space. And we want to develop, requirements and a plan for specific use cases that could handle, attack some of the pain points that you folks have. Specifically, I mean, we did something with the VA, but we just, like to do something with, with state Medicaid agencies and HIEs. And then continue to outreach with various different partners. There's, work with standard bodies, push for broader adoption, and, again, participate in pilots that can help flesh out this technology further. So potential future work is to address some of the elements we didn't show in the demo, how you bind an identity for a user to a particular record of information, and also how do you include UMA into this to provide the mechanism for patient consent and things like that. So, and we also would invite anybody who wanted to do security testing on the pilot implementation to see if there's any issues there. Again, to poke holes in it. And there are some connections to related efforts. There's the Privacy on FHIR, and they're doing they did a set of demonstrations at HIMSS 2015, and MITRE coordinated with the VA Privacy on FHIR team to help share the draft profiles with that team, and we also helped participate in the planning of that. There's also Smart on FHIR, which is led by Josh Mandel. Drop-in capability to enable FHIR in hospitals. And so he's done a lot of interesting work there. There's the Argonaut project, an HL7 initiative to advance FHIR adoption. And they're, reviewing some of the usage of OAuth and OpenID Connect with the ultimate goal of creating an HL7 specification. And that we hope that they can, use our profiles as a basis for that. There's the HEART Working Group, which is, they're actually using our profiles as a starting point. They're looking at OpenID, OAuth 2, OpenID Connect, and as well as UMA, so to put together a system for that, using all three of those technologies. So, and MITRE team members participate in helping to found that group. And then there's also the Healthcare Services Platform Consortium, and we've shared our profiles for consideration in the pilot demonstrations there. There's also a variety of standard organizations that are related to this. There's the Internet Engineering Task Force, which maintains the specs for a lot of these specifications. OpenID Foundation, which handles OpenID Connect. The Kintera Initiative, which is developing the UMA standard, and I think they're going to be more and more important as as time goes on and people get more familiar with these technologies. There's the Identity, Credential, and Access Management Subcommittee, and they are interested in creating federal ICAM profiles of OAuth and OpenID Connect. And so we're hoping to interface a lot more with them. And then there's the National Institutes of Standards and Technology, which work with a lot of these agencies to provide security in federal IT programs. And of course, HL7, which is basing a lot of what their current activities on FHIR and Restful technologies. So you want to help? You can read the profiles and guidance documents. They're all available on GitHub. And see whether the profiles meet your requirements for security and usability. And if not, we sure would like to know why they don't. And are they applicable to your use cases? And let us know what's missing there. You can engage with standards bodies. You can talk to folks in your communities, talk about what the profiles that we've developed, ask about how the efforts are going to profile some of these standards, and offer them up as starting points for standardization work. Without a lot of standardization, again, the interoperability piece doesn't really come into play. And you can engage with software vendors, ask them if they support OAuth and OpenID Connect. And do they support some of the security measures in our profiles, like signed JSON Web Tokens and things like that? And so for more information, you can see our GitHub webpage, Secure RESTful Interface Profile.github.io/pages. All of the software is there. All of this particular presentation is there. The latest versions of the OAuth 2.0 and OpenID Connect 1.0 profiles are there. So it's a really great source of information. You can also go visit the OpenID Connect Heart Working Group, which has basically taken our profiles and are continuing to develop further with it, and including UMA. And so you can visit them at openid.net, working/wg./heart. And that's pretty much it. So thank you for listening, and I'd like, at this point, we can take any questions you might have.
My question is, when we are working with identity and access management system here for the state of Michigan, and I'm representing that solution called MyLogin or MyCam, some of the challenges that we are facing is actually around the level of assurance and multi-factor authentication, as an example, right? And I've seen, some of the diagrams and workflows and use cases.
Any questions at all?
Just 1 second. There's one coming.
So basically, my question is that when I saw the diagrams and some of the screen samples, I saw that, from the logging standpoint, there's a user ID and password provided or email address provided as a measure to authenticate or ensure a person's identity. I guess with this initiative, how that particular aspect is addressed, because I believe it's a CMS requirements, it's actually the state and federal requirement. So I have a question, is it really part of that implementation? I understand UMA is kind of something that's coming along when person is not able to provide their own credentials online, etc., to authorize the access, to that information. But from the MFA specifically, from level of assurance standpoint, how is it getting addressed in this pilot and in this implementation?
All right, so there's a couple places where authentication occurs. One of them is in each of those authorization servers in both of the different security domains that you saw, and also at each of the identity providers. So at those points, you plug in whatever authentication you want into, in this case, the software we use is MITRE ID Connect. By default, it just uses username and password, but you can implement your own layer of multi-factor authentication onto that part of it to authenticate the user to those various servers.